Hello and welcome back. Today we are talking about section 1.3, lines and linear functions, and we're going to discuss what is, for us, our final learning objective, this third one, study parallel and perpendicular lines. So let me just jump up to that. So parallel and perpendicular lines are basically just a special description of what can happen with lines that we've already been exposed to. So it's important that we start with two non-vertical lines, that is, neither one of them is vertical, just for the purpose of some technicalities here. So two lines are parallel when their slopes are equal to one another. That's pretty convenient. So that visually would mean that their graphs in the plane would have the same rise and run to them, roughly something like that, two train tracks, as it were, sometimes described. And that means that if we view them in the plane, we can have a good guess about whether they're parallel or not, but we're never really totally sure unless we can see their equations. That being that, the reason for that being that if they were very slightly bent toward one another, for instance, maybe that's not visible to the human eye, but their equations would reveal that, in fact, their slopes weren't perfectly equal. So equations are kind of the place to go if we want to know for sure. And then they're perpendicular. This is slightly more complicated, but when the product of their slopes is -1. And if you recall, product just means that this takes the two values and multiplies them together. So you have a slope 1, a slope 2, multiply them. If you get -1, then you have perpendicular lines. And then just to address this whole vertical line situation, so if you take two vertical lines, if you take two vertical lines, they must be parallel to one another. If you take a vertical and a horizontal line, then they must be perpendicular. So these just sit outside of the definitions, mostly because if you think about a vertical line, the slope is undefined. It's very difficult to talk about one undefined thing being equal to another undefined thing. So we just take vertical lines out of the picture and then make a special definition down here at the bottom. Okay, so we're going to do two kind of parallel tasks, if you'll pardon the pun. We're going to be given the equation of a line. It's not in our handiest format, but it definitely still is the equation of a line. And we're going to accomplish two things with it. Is the line y equals 6 minus x parallel to this thing? And then the next we'll have to tackle is finding an equation of a line that's perpendicular to this original equation. First things first. Is this line parallel to the one we were given? So if you before we get to the solution, just thought process wise, you can think, okay, if this was our equation, then knowing something about its slope would be really useful to compare to this equation in order to decide about parallel or not. And one of the most convenient ways we can write an equation is in its slope-intercept form. And that reveals to us exactly what its slope is. So that's our first task. We're going to take this equation and we're going to write it in this more convenient form because we know that if it's in this format, the coefficient, that is the constant being multiplied to x, is going to describe for us the slope perfectly. So we've got a little bit of algebra ahead of us, nothing too overwhelming, but we've got things next to y, which should probably get out of the mix if we want to have y all by itself, just like this y equals mx plus b form looks. So if we add x to both sides, add 9 to both sides, there we are. We're close to having y isolated. Last thing to do is divide both sides by 2. So now we've got, you could think of it as x over 2, but probably more convenient is thinking about it in this format, because now we know the number exactly multiplying 2x. So we have a half sitting out in front there. And then something that may not be all that important to us, because when we're talking about parallel and perpendicular lines, slope is really where it's at. So what do we know? We know that the slope of our current line is a half, and the slope of the line we were given, if you recall, 6 minus x, that's going to have a slope of -1. 6 minus x. So we can determine that by simply saying, oh, I wrote it here and it's right up there, man. It just illustrates how third grade the handwriting is. All right, so we have -x, but really there's a 1 sitting here. So when we think about slope, this is a slope of -1. So -1 and 1/2, well, for parallel, all we have to do is compare whether or not they're equal to one another. And 1/2 certainly is not equal to -1, so the lines are not parallel. Task 2, equation of a line that contains this and is perpendicular to the one. that we were given. So here's our original equation. And we figured out in part A, so might as well use the work, the hard work we've already put in. We know it had a slope of a half. And then revisiting our definition of perpendicular lines, we know that if we take the slope of our new line, which we don't know yet, and multiply by the slope of our current line, 1/2, we're supposed to get -1. This is just how perpendicular lines are defined. So in other words, we could treat this as an equation and solve for the unknown, the slope of this other line. And all that's required to do that is to multiply both sides by 2 to get rid of that 1/2. So if we multiply by 2, we get -1 times 2, or slope equal to -2. But we're not actually done. Remember, we were supposed to find the equation of a line. We found the slope. That's a good start. In fact, it's maybe the most important piece, but it's not the completed equation yet. So what's left to us to do is, as we did if you watched the previous video, if we've got a slope and a point, then what we have to put together is an equation involving those things. We could go straight to y equals mx plus b, nothing wrong with that at all. We've also got a point slope formula that we could use. So this method illustrated here is the one that involves a point slope formula. So you may recall that this requires us to write y minus y naught and m times x minus x naught. This was a point we were handed. We haven't made use of this yet, so let's bring our attention back to it. But if you recall in the statement of this part B task we were given, we're supposed to find the equation of the line that contains 1, 4. So that's why we're breaking out this point here. We figured out the slope using the notion of being perpendicular to the original line, and now we've got the point to help us finish out the point slope formula. So there we go. X is 1, y is 4, slope is -2, which we figured out just a minute ago, and it's all done but the shouting. So -2x, now we have -2 times -1, which is +2. And again, we're not quite done yet because we've got -4 to bring over. So we had 2 plus 4, that gives us our final constant of 6. So that's it for this learning objective and for 1.3. We'll be back shortly with section 1.4.